Welcome back to another tutorial of real numbers chapter 1 of 10th class. So before moving on to the next exercise, that is 1.5, we are going to look at some rules and theorems that we are going to use in this exercise. Exponential we have seen in the previous video. Now we have logarithm along with exponential. So it's exponential and logarithm. If 2 power x equals to 5, then x is logarithm of 5 to base 2, and it is written as log 5 base 2. The 2 which is down is known as the base. So the first theorem we have is of product rule. So what does this rule say? Just as the previous thing in the exponential, when we have multiplication, we need to add those things. We have seen this in the previous video. Just check it out if you don't understand. Let a, x and y be the positive real numbers with a is not equals to 1. Then log of xy with the base a equals to log of x base a plus log of y with the base a. That is, the logarithm of a product is the sum of the logarithms. When there is a product, we need to do the sum. That is what it says. Okay, here is the proof how we are going to solve. Let log of x with the base a equals to m and log of y with the base a equals to n. Then we have a power of m as x, a power of n as y. If x into y is in the form of a power of m into a power of n, then we have the same basis, power should be added. That is what the exponential form was there in the previous video. Similarly, when it comes to the logarithm, log of x into y with the base a equals to log of x with the base a plus log of y with the base a, where log of x with the base a is m and log of y with the base a is n. So the next rule we have is quotient rule. So what does this theorem says? Let a, x and y be the positive real numbers where a is not equals to 1. Then log of x by y with the base a equals to log of x minus log of y. When there was a product in the previous question, right? We have product in the previous question, so we need to add. When there is division, then we need to subtract. That is what these rules says. Now there is a division, then we do it the subtraction. It is in the form of by, means division, so subtraction. Let log of x base a equals to m and log of x base y equals to n. Then we have a is equals to x and a is equals to y. X by y equals to a power of m a by a power of n, which is equals to a power of m minus n. This was the form of exponential. Now in the form of logarithm, we have log of x by y with the base a equals to log of x with the base a minus log of y with the base a, where this is log of x with the a, log of y with the base a. So what does this say? Logarithm of quotient of two numbers is equal to the difference. Just as I said, when it's product, it's addition. When it's quotient, division, then it's subtraction. The next one is the power rule. When an exponential expression is raised to the power of power, means one power by on the top of another power, then we need to multiply those powers. This was the same as expression in the exponential rules. We also have this in the logarithm rule. Let's see. Power rule. Let a and x be the positive real numbers with a is not equals to 0 and n be the any real number. Then log x power n with the base a equals to, we need to bring this n here. That is how it is done. N log x with the base a. Moving on to exercise 1.5. Let's look at the first question. Determine the values of the following. So log 5 with the base 25. This 25 can be written as 5 into 5, right? So it is 5 square. Now when we have this power here, it comes here, right? That is what we have seen in the previous rule. So it is 2, it becomes 1 by 2. If it is in the power, it goes in the division. 5 and 5 as it is. So see, this is what this theorem says here. Log n with the base a power of m goes as this m comes here, 1 by m log n with the base a. That is what we have done here. Now when we have two same numbers as base and beside the log, then it turns, this whole thing turns as 1. Half half, same as log 5 with the base 5. We have both 5 here, same numbers, it becomes 1. As log a with the base a becomes 1, similarly log 5 with the base 5 becomes 1. So half into 1 is half. Next, log 3 with the base 81. 81 can be written as 3 power 4. 3 into 3, 3 into 3 equals to 81. Again, we will take this 4 in front, 1 by 4, log 3 with the base 3. I forgot to mention the 3 here. Let's write it properly. Right? Now, again we have it in the form of 2, 3 same numbers. Log a of a, log a of a, which equals to 1. And this is in the form of this. So 1 by 4 into 1 is 1 by 4. Third question, log 1 by 16 to the base 2. Now 16 can be written as 2 power 4. So when this 2 comes up, this is in the division, so it turns into the minus form, right? This is what the exponential expression says. 1 by a power m is equals to a power of minus m. Again, we'll bring this 4 in the front, the logarithm power rule, 1 by 4 log 2 with the base 2, right? Again, we have both 2 same, then this whole thing turns as 1 minus 4 into 1 equals to minus 4. Log 1 to the base 7 equals to 0. Why? Any value of log 1 to any base is equals to 0. The value of log 1 to any base is always equals to 0. Fifth one, log root x with the base x. Now root x can be written as x power 1 by 2, right? That is how the root can convert. Here it is. Then again we will bring this half in the front, 1 by 2, log x with the base x. Then again x same, it turns into 1. Half into 1 is half. Similarly, we have one more question, that is log 512 with the base 2. 512 can be written as 2 power 9. When you multiply 2 9 times, it gives 512. Again, let's bring the 9 here. 9 log 2 base 2. This whole thing turns into 1. 9 into 1 is 9. Seventh one, log to 0.001 with the base 10. Now, if we convert this 0.001 in the fractions form, this is what we get, 10 power of minus 2. We have two numbers here, so it goes, we get 2 zeros in the denominator. These 2 zeros get power 2. When we take this power 2 to the numerator, it turns into minus 2. Let's bring this minus 2 here. Minus 2 log 10 with the base 10. Again, we have same bases. Base and the number are same. Log 10 with the base 10. When these two are same, then it turns into 1. 2 into 1 is 2. I wrote an extra 0 here. Let's just cut it out, okay? Moving on to the 8th question. It is log 8 by 27 with the base 2 by 3. Now 8 by 27 can be written as 2 by 3 whole cube. 8 into 8 into 8 is, 2 into 2 into 2 is 8. 3 into 3 into 3 is 27. As everyone knows, 2 into 2 into 2 equals to 8. 3 into 3 into 3 equals to 27. So it can be written as 2 by 3 whole cube. Then again this cube goes here as 3 log 2 by 3 with the base 2 by 3. This whole thing log 2 by 3 with the base 2 by 3 turns into 1. We have similar things here. 3 into 1 is 3. Next question. 2 to the power of 2 plus log 3 with the base 2. Now, another exponential formula is when we are in the product, we need to sum up the powers, right? Already have it in the form of sum, so we need to do this thing. We got the right hand side, we need to make it to the left hand side. We already got the right hand side, which is 2 plus log 3 with the base 2. Let's move it to make it as a right hand side. We need two 2's in the form of product, m and n. This should be 2 square here. Square is missing. right? That is what make m and n. This is the value of m and this is the value of n, right? We got this and we are converting it to this side. As we got this here, I'll just connect it like this, right? So we are connecting this whole thing as this. So this is the value of m here, this is the value of n. So 2 square is 4, and now with the help of another logarithm rule, that is a power of log n with the base a equals to n. So what's the value of n here? 3. So it is the value 3. 4 into 3 equals to 12. Moving on to the next question. Write the following expression as log n and find their values. Log 2 plus log 5. When we have addition, we need to do the sum, right? Just as exponential form, we got addition, we need to multiply. Log 2 into 5, log 10. Just as the value of log 1 with any base is equals to 0, we have the value of log 10 with any base always equals to 1. Again, log 16 with the base 2 minus log 2 with the base 2. Now, as it is in the subtraction form, we need to convert it into division. Just in the previous one, when it was in the addition, we did the multiplication. Now we have in the subtraction and we are doing it in the division form. So we have same basis, 16 by 2, 2 ones are 2, 8 are 16, log 8 with the base 2, 8 can be written as 2 power 3. Let's bring this 3 again here with the logarithm rule. 3 log 2 with the base 2. Again, this whole thing turns into 1. 3 into 1 is 3. The answer is 3 here. Typo mistake. Sorry for that. Now, 3 log 4 with the base 64. Now, base 64 can be turned as 4 cube. 4 into 4 into 4 turns 64. Let's send this 3 here. It goes in the form of division. 1 by 3. Power goes to the division. 3 into 1 by 3. Log 4 base 4. 3 cancel, remaining 1. Then log 4 with the base 4 again turns into 1. 1 into 1 is 1. Fourth question, 2 log 3 minus 3 log 2. Let's send this 2 here. When there is in the power, we can send those here. When these are here, we can also send those in the power. So log 3 square minus log 2, this goes as a cube. 3 square is 9. 2 cube is 8. As it is in the subtraction form, we'll make it the division one. Next, log 10 plus 2 log 3 minus log 2. Okay, log 10, we'll send this 2 again here. 3 power 2, there is nothing to send, goes as it is. Now, this is in addition and this is in subtraction. So, the addition things convert into multiplication. The subtraction thing converts into division. So, 3 square is 9. 10 log of 10 into 9. This addition turns into multiplication. Minus 2. This subtraction turns into division as by 2. 2 ones are 2. 2 fives are 10. It cuts as, then 5 into 9 equals to 45. Third question. Evaluate each of the following term of x and y if x is equals to log 3 of 2 and y is equals to log 5 of 2. So we need to get these values at the end. Log 15 to the base 2. 15 can be written as 3 into 5. Again, we have it in the multiplication. We can convert it in addition. Addition can convert to multiplication. Multiplication can convert to addition, vice versa. Same goes with the division. Division can convert to subtraction and subtraction can convert to division. So, this multiplication converts to the addition. Log 3 to the base 2, log 5 to the base 2. We got this x and y. X plus y is the answer. For the second question, log 7.5 by 2. We are removing this point, means we need to add 0 at the denominator. We have one value before the point, so we need to add only 1 0. 75 by 10. Now 75 can written as 15 into 5, right? Again, this can cuts off. 5 2s are 10, 5 3s are 15, 3 5s are 15 by 2. 15 by 2 with log with the base 2. Now it is in the division form. It turns into subtraction, as we have already said. So log 15 with the base 2 minus log 2 with the base 2. Again, log 2 common. This 15 can also written as 3 into 5, right? This log 2 with the base 2, this whole thing turns into 1. Now this is in the multiplication and this is in the subtraction. If we open this up, this multiplication can turn into addition. Log 3 with the base 2 plus log 5 with the base 2 minus 1 as it is. So it is in the form of x and the value of y minus 1. Now the third question, that is log 60 with the base 2. 60 can be written as 2 power 2 into 3 into 5, means 4 into 3 into 5 equals to 60. Now when these are in this multiplication form, we can turn them into the addition, right? Log 2 square with the base 2 plus log 3 with the base 2, again log 5 with the base 2. Now we'll send this 2 here. 2 log 2 with the base 2. Now this is x and this is y. Again this whole log 2 with the base 2 turns into 1. 2 into 1 is 2. 2 plus x plus y is the answer. Now the fourth one, that is log 6750 with the base 2. Again we need to open 6750 just as we opened 60 in the last question. So we don't know the fractions, it's a big number. So let's take the LCM. 2 3s are 6, 2 3s are 6, 1 remaining, 2 7s are 14, again 15 minus 14, 1 remaining, 2 5s are 10. Let's take 3, 3 1s are 3, 3 1s are 3, 3 2s are 6, 1 remaining, 3 5s are 15, again 3, 3 3s are 9, 2 remaining, 3 7s are 21, 1 remaining, 3 5s are 15, 3 1s are 3, 3 2s are 6, 1 remaining, 3 5s are 15. 5 25s are 125, 5 5 is 25, 5 1s are 5. So these are the factors that we got. Let's put those here. 2 power 1, 3 power 3, 5 power 3, we have 3 5, 3 3, only 1 2. Again, let's turn these multiplications into the addition form. Log 2 with the base 2, log 3 cube with the base 2, log 5 cube with the base 2, right? Now log 2 with the base 2, same numbers, goes 1. Let's send this 3 here. Log 3 with the base 2, let's send this 3 here. 3 log 5 with the base 2. Now again, this whole thing is the value of x and this whole thing is the value of y. So 1 plus 3x plus 3y is the answer. Thank you. Rest of the questions will be explained in the next video.